So today we're going to finish up the examples in Chapter 9, Section 1, and we're going to be solving the nonlinear systems. So this was the suggested method that you would use in this lesson. However, some of the questions are better set up to be solved using elimination. And that's what we're going to officially see in Section 9-2. We're going to see the elimination method and the graphing method. All right, so then we did the linear examples, which again, you should have done in your Algebra 1 course. Same thing with the word problems. These were linear. And then this is where we saw the nonlinear systems, and those are going to be equations that have exponents. We did these 4 examples, and this is where we are now. So we're going to do these last 4 examples, and I'm going to do the first one. I'm going to do it with elimination. It'll be a lot easier because if you look at the system, notice both equations have exponents. But if you look at the y's, notice the y's are set up and one has got a positive 1 in front and this one's got a negative 1 in front. So if you just decide to add the 2 equations together, that's going to eliminate the y squareds. And then I'm just going to add 1x squared plus 2x squared gives me 3x squared. And then 4 plus 8 gives me 12. I'm going to divide both sides by 3. And x squared equals 4. Now I need to find the value of x. Remember, whenever you square root to solve, you get 2 answers. Positive and negative 2. So now what I have to do is take both of my x values, x equals 2 and x equals negative 2, and substitute it back in to one of my original equations. It doesn't matter which, you can choose. It looks like to me the first equation will probably be less work, and that's what I always look for, so I don't make any kind of simple calculation errors. So I'm going to do x squared plus y squared equals 4. I'm going to use this equation twice because I'm going to end up with 2 solutions here. So I'm going to plug in a positive 2. And I get 2 squared is 4. And then I'm going to subtract the 4. And then I get y squared equals 0. When I square root this, there is no positive and negative 0. It's just going to be y equals 0. So my first solution is 2, 0. I'm going to do exactly the same thing with the negative 2. But notice once I plug it in, I'm going to end up getting the exact same simplifying process. Because negative 2 squared is positive 4. Subtract the 4. Y squared equals 0 again. So y equals 0. So the 2 solutions to this system are 2, 0 and negative 2, 0. Now, WebAssign is going to want you to enter the smaller x value first. So you would enter the negative 2, 0 first, and then in the second box, put in the positive 2, 0. Just read how they want you to enter the solutions. So over here, we've got, looks like a really busy system here. I'm going to do the elimination method again. And what I'm going to do is I'm going to choose to multiply one of my equations by negative 1. Because if you notice, if you try to just add these right now, nothing eliminates. So when you do the elimination method, what we're doing here is we're going to be multiplying one or even both of the equations by a number to get either the x or the y to cancel. So if I take my second equation and if I multiply all 4 pieces of this by negative 1, I get negative x squared plus xy minus y squared equals negative 6. I distributed a negative 1 to each of these. I'm now going to take the first equation and I'm going to write it right on top. So my goal is to get either X or Y to cancel. So my goal is to try to make either the X's or the Y's to have the same number but opposite signs. Now notice when I do this though, not only is my Y going to cancel, so is my X squared. So they both cancel, but I still get this to add together. 3xy plus 1xy is 4xy, and then 22 minus 6 is going to give me 16. I'm going to go ahead and divide both sides by 4, and now I have x times y equals 4. I need to get what either x or y equals. It doesn't matter. I'm going to go ahead and solve it for y. So I'm going to divide both sides by x, and my y is now equal to 4 divided by x, or 4 over x. This is what I'm going to substitute. So now I'm using both methods in the same problem. I first did elimination, now I'm doing substitution. Now, it doesn't matter which equation you substitute it back into. The second one here looks like going to be the simpler one to substitute. So I'm going to go ahead and write down my second equation here. My x squared minus xy plus y squared equals 6. I'm going to take out my y's, and I'm going to replace the y's with what I just found y equals. So I get x squared minus x times 4 over x plus 4 over x squared equals 6. Now, if you noticed back up here, before we divided, I could see that xy equals 4. So you could have also said, well, I know xy is 4. You could have just put a 4 there. But if you want to stay consistent because you solved it for y, once you multiply this here, the x's cancel. So then this just becomes x squared minus 4 plus 16 over x squared equals 6. And I really don't need to put parentheses around this. I could just leave it the fraction. So what I'm doing here now is I need to solve for x. So I'm going to go back to what I did at the very beginning of the school year, and I'm going to get rid of that x squared in the denominator. I'm going to clear the fraction. So I'm going to multiply my entire equation by x squared. So I'm going to distribute x squared here, and I get x to the 4th. I'm going to distribute it here, and I get negative 4x squared. Now, when I go to distribute it here, the x squareds cancel. So then I'm just left with plus 16, but I also have to distribute it to the 6. Every single piece needs to get that x squared distributed to it. I now need to combine my like terms. So I'm going to go ahead and subtract 6x squared, because I'm going to set my equation equal to 0, because I'm solving for x. So I get x to the 4th minus 10x plus 16 equals 0. I now can factor, this has got an x squared here. I can now factor this trinomial. If you want to think of this as just being like quadratic, x squared minus 10x plus 16, think of that. But when you go to make your binomials, you're going to have an x squared. So what I'm looking for are two factors of positive 16 that will combine to give me negative 10. And those two factors are going to be negative 8 and negative 2. So when I go to put it in my binomials, x squared minus 8 and x squared minus 2. I need to solve each one of the binomials, set them equal to 0. So x squared minus 8 equals 0, x squared minus 2 equals 0. I'm now going to add 8 to both sides. x squared equals 8. Whenever I'm solving for a variable squared, I have to square root it. And this is going to give me positive and negative square root 8. But I need to simplify that radical. I can make it 2 times 4, which gives me 2 radical 2. Then over here, do the same thing. Add the 2. X squared equals 2. Square root it. And x is equal to positive and negative square root 2. This is going to give me 4 solutions. So I'm going to go ahead and now I got to plug them in. Now, I'm not going to plug them into one of the originals because that's going to be way too much work. I can go back over here and plug it in to the one that I rearranged, that I simplified by doing the elimination. So I'm going to take my y equals 4 over x. This is what I'm using to get my 4 y values for each one of these x's. Because what I need to do is I need to first solve it for x equals positive 2 square root 2. I need to get a y value for negative 2 square root 2. And then I need to get one for positive square root 2 and then negative square root 2. So I'm going to plug in these 4 x values into the y equals 4 over x to get the y of my order pair. So for this first one, if I just do y equals 4 over 2 times the square root of 2, I need to simplify and rationalize. If I simplify this, 4 divided by 2 is 2 over the square root of 2. Rationalize. And I get 2 square root 2 over 2, which then now can simplify, and it's just square root 2. So my first solution, 2 square root 2, and then the y value is square root 2. Next, I'm going to plug in negative 2 square root 2. So for this one, y equals 4 over negative 2 square root 2. Again, simplify it. 4 divided by negative 2 is negative 2. And then I still have the root 2 in the bottom. Rationalize. Negative 2 root 2 over 2 simplifies to just negative square root 2. So my next solution, plugging in a negative 2 square root 2, gives me a negative square root 2. Got to do it again now with this next x value. So here, y equals 4 over the square root of 2. Again, rationalize. 4 square root 2 over 2. I can simplify the 2 outside numbers, and it's 2 square root 2. So my next solution, square root 2, and then 2 square root 2. Then next, plugging in a negative square root 2. Switch colors here. So for this one, y equals 4 over negative square root 2. Rationalize. This gives me 4 square root 2 over negative 2. I'll divide it, and I get negative 2 square root 2. So the last solution, negative square root 2 for the x, and negative 2 square root 2 for the y. To use the elimination method, you don't necessarily have to just multiply by a negative 1. You can multiply by numbers other than that, because your goal is to get either x squared or the y squared to cancel. I'm going to go ahead and try to cancel the y squared. So what I'm going to do is I'm going to multiply my first equation here by a negative 3. You could have also chosen to eliminate x and multiply by a negative 4. It doesn't matter. So once I distribute a negative 3 to all 3 of the pieces, I get negative 3x squared, negative 3y squared, and negative 15. I'm now going to add these 2 equations together. Notice what's going to happen here is the y squareds cancel. but then I'm going to go ahead and add 4x squared plus negative 3x squared, and I just get x squared. And then this is also going to give me a negative 15 here. So when I distribute the negative 3 there, and then 11 plus negative 15 is negative 4. As soon as I square root this, I end up with positive and negative 2i. For WebAssign, the answer is no solution, no real solution here, because we don't want any imaginaries. Now, if it would have said to find all solutions, then we would have had to plug in that 2i. But for our test and for the WebAssign homework, if you get an imaginary solution, stop and say no solution. Okay, so for number 12, I'm going to take the second equation, because it doesn't have an exponent, and I'm going to solve it for y. And I'm going to do substitution on this one. So I'm going to take my second equation, the x times y equals 2, and I'm going to solve it for y. So I'm going to divide both sides by x, and y is equal to 2 over x. And now I'm going to do the substitution method, and I'm going to take what y equals, and I'm going to plug it in. So I'm going to take my top equation. Whenever you do substitution, you can't substitute into the same equation you rearranged. So again, I'm going to take out the y, and I'm going to put 2 over x here. So 5x squared minus 2, and then 2 over x squared equals 6. I need to follow order of operations. I don't multiply first. I'm going to take care of the exponent first. So 5x squared minus 2. I'll evaluate the exponent. So 2 squared is 4, and x squared is x squared, and then the 6. Now I can multiply the 2 and the 4. And then I'm going to do just like I did above. I want to clear this fraction. I don't want to leave the x squared in the bottom. So I'm going to distribute x squared to all 3 pieces. And then that will clear the fraction. So I'm going to go ahead and distribute. And I end up getting 5x to the 4th. On the second time, when I distribute it to the negative 8 over x squared, it just cancels the x squared. And then the last one becomes 6x squared. Now I'm going to go ahead and set my equation equal to 0 by subtracting the 6x squared. And I get 5x to the 4th minus 6x squared minus 8 equals 0. I now need to factor this trinomial. And again, if it couldn't be factored, I would do quadratic formula. Even if it, in this case, it's an x to the 4th, so I couldn't do quadratic formula. I have to factor it. So what I'm going to do here is multiply the beginning times the end. So I'm looking for 2 numbers that'll multiply to give me negative 40, but who will add to give me negative 6. Those 2 factors are going to be negative 10 and positive 4. Now, if you'd rather guess and test, you can, but I'm going to do grouping. So I'm going to rewrite the first term. I'm replacing this 6x, this negative 6x squared with the 2 factors I just found. So I'll go ahead and put in the negative 10x squared. These are going to have x squareds with them because I'm trying to get x to the 4th. And then positive 4x squared. And then the minus 8 from the original equals 0. I'm going to go ahead and make some groups here. My greatest common factor of the blue group is going to be 5x squared. I'm going to divide. My greatest common factor of the red group is going to be positive 4. I put the two GCFs together. This becomes my first binomial. So 5x squared plus 4, and then the binomial in common. I set each of the binomials equal to 0. Going to subtract the 4. 5x squared equals negative 4. Divide by 5. And x squared equals negative 4/5. Now, I don't want a negative under the radical, so once I do this, I get x is equal to positive and negative 2I over radical 5. So if you had to keep going on this, you would rationalize, and then you would get 2I radical 5 over 5 plus or minus, and then you'd have to plug it in if it asked for all solutions. But as soon as you got the I here, this part is not going to give you any answer. However, the other one will. So we got to keep going on the other factor. So I'll add 2. X squared equals 2. Square root both sides. And x is equal to positive and negative square root 2. So now I got to find the corresponding y values for each of these x's. And again, you can either choose to go back to the beginning and plug it into one of the originals. But again, I'm going to find the simpler route, which is going to be right here, and use the y equals 2 over x. So I'm going to first do it with the positive square root 2, and then I'll do it again with the negative square root 2. So I'm going to get y equals 2 over the square root of 2. Got to rationalize. This will give me 2 square root 2 over 2. The 2's will simplify. And then your y value is just going to be square root 2. So my first solution is square root 2, square root 2. And then I got to do it again with the negative square root 2. So 2 over negative square root 2. Again, you're going to rationalize. And you get y equals 2 square root 2 over negative 2. Again, this will simplify. And this becomes a negative 1 here. So your y value is just negative square root 2. So the next solution is just negative square root 2, negative square root 2. And these will be your two solutions.